Hey everybody, so let's carry on with 4C, transformations, quadratic transformations, chapter 4.3. You should have watched the Desmos video first, so 4C part 1. If you haven't, go watch that video first before watching this one. Okay, so to piggyback off of that Desmos video, let's start with drawing our parent function. Okay, so label this x, label this y. Okay, now, what are the x and y values that I'm going to choose? Well, I'm going to randomly choose the x values. So -3, -2, -1, 0, 1, 2, 3. The corresponding y values are 9, 4. Now, how am I getting that? -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, now let's plot these points. So -3, 9 would be my first point. -3, 9, so that's here-ish. Oops, sorry, -3, 9. Okay. Next point is -2, 4. Next point is -1, 1. Ooh, what happened to my -3, 9? I don't know why it keeps doing that. Next point, based off of our table, is 0, 0. And then 1, 1. And then 2, 4. And then 3, 9, 8. Okay. Now, we are going to sketch, well, I am going to sketch my first parabola using this tablet thingy. Wish me luck. So, I'm going to go like down here. Let's pretend I hit that point. Now, normally, when you're trying to draw these parabolas, there are a few things to keep in mind. You want to keep the vertex smooth. Okay, it's supposed to be a smooth curve, and it's not supposed to be pointy. Oh, that's brutal. But let's just assume those crosses those points. I give myself a pass for my very first parabola. Okay. Now, typically when you're drawing this parabola, a little trick is to turn the paper as you're drawing the curve. Now, I don't think my tablet likes that too much, so this will have to do for now. Here is our parent function. Okay. Over time, you're going to realize the parent function, y equals x squared. You can just remember the numbers 1, 3, 9, or sorry, 1, 1, 2, 4, 3, 9. And knowing that it's symmetric, and the axis of symmetry in this case is the y-axis, which is going to be x equals to 0, we'll cut this exactly in half. So if you know the points on one side, realistically, you also know the points on the other side because it's perfectly symmetric. Okay. Now, based off of the Desmos video, there were 3 main transformations we focused on. This one. This value right here tells us our vertical shift. Up, down, by whatever the k value is. Okay. This variable in front, this gave us our vertical shift. This gave us a vertical shift. Now, no, sorry, no, not vertical shift, I lied. Vertical stretch / compression. Okay. Now, what were the rules again? If A was bigger than 0, but less than 1, it's a vertical compression. If A, so I'm going to draw little absolute signs around them. I'll explain what they are in a second. Okay. If the absolute value of A is bigger than 1, it's a vertical stretch by whatever the absolute value of A is. Oh, whoa. I'm guessing there's a bit of a delay there. Okay. Now, what do these absolute value symbols mean? For now, just understand that the absolute value symbol just tells us that we're only focused on the value itself. So, for example, the absolute value of 3 is just 3. We're looking at the positive value of that. Whereas the absolute value of -3 is just positive 3. Absolute value of -2 is just 2. Absolute value of 2 is still just 2. Okay, we're looking at the positive value of that. Now, why are we looking at the absolute values? Because y equals -2x squared, let's say. Okay, this would be my a value, right? Now, if I were to ask you, is that a vertical stretch or compression? The correct answer would be that it's a vertical stretch, okay, by 2. Okay, vertical stretch by 2. Now, you look at that and go, okay, absolute value of a has to be bigger than 1. If I didn't have the absolute value signs there, you would look at that and go, wait, -2 is not bigger than 1. You would be correct, okay? But, yeah, so if we looked at the absolute value, the 2 tells us the absolute value of -2, absolute value of -2 is 2, and that is indeed bigger than 1, so there is a vertical stretch by, in this case, 2. Okay, now what does the negative sign tell us then? So the negative sign tells us, let's just use, what color should I go with here? Closer, that's it, oh, there. Let's go with green, okay? So the negative sign, negative a value, tells us there is a vertical reflection on the x-axis. So in other words, pretend there is a mirror overlapping the x-axis. Okay, so that entire graph is just being flipped on the x-axis. Okay. And let's scroll down. Okay. Last but not least, this was our, let's go back to red. This was our whoa, this is way too thick. Horizontal shift, left or right by h. Okay, so sorry about that color. It's okay. So for example, if I had y equals x minus 3 squared, so it would be the parent function shifted right by 3. Y equals x plus 2, let's say, squared. So that would be shifted left by 2. Okay? Alright, now what I want you to do and to submit is this. You are going to have to list the transformations and the equation of the transformed graph. Well, what transformed graph are we talking about here? Well, if you open up the worksheet titled 4C Transformation Worksheet, you will see a bunch of graphs. Okay, so if you look at question number 1, you should see the fact that, let me just switch screens, you should see 2 lines. One that's dotted and the other one that's not. Okay, the dotted line is going to be your, so let me just write that up top, dotted is your your parent function. Your parent function. No. Oh, phew. Okay, parent function y equals x squared. Okay. Now, I want to know, how do you get from the dotted line, not the dotted line, the dotted parabola to the transformed parabola. Okay. So in this case, the transformation, it was, number one, was shifted down by 4. Shifted down by 4. By 4. Okay. So that would, the new function then would be y equals x squared minus 4. If you graph this on Desmos, you should see the exact graph of your solid parabola. Okay, if you graph this in Desmos, you should see the exact graph of your dotted parabola. Okay. Now, the other thing to keep in mind, though, is to make sure that there is no vertical stretch or compression. Okay, and how do we do that? Well, I'm going to record another 1 or 2 minute video after this for questions number. Let me scroll down. Give me 1 second here. Give me 1 second. I'm searching for one that might have number 9. Yeah. So I will do a quick video on question number 9. Okay. All right. So make sure you finish this sheet, submit this part, okay, as well as these homework questions. You can submit it as 1 file, you can submit it as 2 file, that's fine. Make sure your name's on it, okay? All right, bye.